Welcome to section 6.5. This section is about variation. There's going to be three main types of variation that you work with. There's direct variation, inverse variation, and joint variation. At the end, we'll also do combined variation, which kind of puts all of them together into one problem. In general, a variation equation just relates one variable to one or more other variables through multiplication or division. There should be no addition or subtraction in these problems. The first type of variation we're going to work with is called direct variation. In direct variation, the values of the two variables increase or decrease together. So as one increases, the other one increases. As one decreases, the other one decreases. So for example, you could say something like, the more I eat, the more I weigh. That would be an example of direct variation. You could also say, the less I eat, the less I weigh. Notice that the two variables travel in the same direction together. Whenever you go to write a direct variation equation, you always start with your basic form, which is y equals k times x. The k is called the constant of proportionality. Sometimes people just call it the variation constant. Every direct variation problem will have this format. So keep that in mind when you start reading the story problems. Okay, so let's look at the first example. The resistance of a wire R varies directly as its length, L. Write an equation for the resistance of a wire R if the constant of proportionality is 0.008. Okay, so I always do a verbal translation first. So it says the resistance of a wire R, so I'm going to write my R down, varies directly. So that means we can put our equal sign in, we can put our constant of proportionality k in, and the k will be multiplied by something. It varies directly as its length L. So the k is going to be multiplied by L. Now, in this problem, they told us the constant of proportionality. They said the constant of proportionality was 0.008, so we can fill in our k value with 0.008 L. And you have created a direct variation equation. Usually they'll have you do more with the equation after you've created it, but in this first example, all they wanted you to do was write the equation. Here's a little more in-depth example. The area A of a picture projected on a movie screen varies directly as the square of the distance D from the projector to the screen. Okay, so if it was me, I would stop right there and I would get an equation on my paper. Okay, so picking apart what it says A, so I'm going to write that down, varies directly, so we're going to multiply the k, as the square of the distance D. So you don't want to use just D because they used the word square of the distance. So you'll have to take D and raise it to the second power in order to get the square of the distance. So for me personally, that's always my first step, is my verbal translation. Now, in the next sentence, they should give you some information so that you can figure out what your k value is. So let's check it out. If a projector at a distance of 25 feet, so that's your distance, which was D, projects a picture with an area of 100 square feet. That's your A. So I'm going to stop there. Even though the sentence goes on, I'm going to stop there and I'm going to use that information to figure out my K. All right, so the first thing I'm going to do is square my 25. If I take 25 squared, I get 625. And the way I'm going to get my k alone is I'm going to divide each side of the equation by 625. And so k will be equal to 0.16. So I would probably opt to rewrite the equation at this point and write it as A equals 0.16 d squared. You're going to use this equation to answer the question that they've given you. Okay? So the question says, what is the area? So we're looking for the area. We do not know what it is. Of the projected picture when the projection is a distance of 40 feet. So they told us the distance in this problem. So where the D is located, we can fill in our 40. Order of operations says you should do the exponent first. So 40 squared is 1,600. And then you can take the 1,600 times the 0.16, which will give you the area of 256. Now you should do proper labeling. Since they measured all the distances in feet, your area will be square feet. The second type of variation you're going to run into is called inverse variation. In inverse variation, as one quantity goes up, the other quantity goes down. Sometimes they'll call them inversely proportional. So for example, the more I exercise, the less I weigh. Notice the quantities go in the opposite directions. That is inverse variation. Whenever you're trying to write an inverse variation equation, you will still have a y, a k, and an x, but you're going to take the k and divide it by the x. That is the only difference. In direct variation, it's y equals k times x. In inverse variation, it's y equals k divided by x. K is still called your constant of proportionality. That is not going to change. So let's look at another situation where we have a direct variation problem, an inverse variation problem. The illuminance I of a light source varies inversely as the square of the distance d from the source. If the illuminance is 80 units at a distance of 5 meters, determine the equation that expresses the relationship between the illuminance and the distance. Okay, I like to break it down into steps. I don't like to do it all in one. So first thing I like to do is to find my verbal translation. Okay, so they said illuminance varies inversely as the square of the distance d. Okay, so illuminance is your I. I is varying inversely, so we're going to take the k and divide it by the d. But it's not just I is inversely as distance. I is inversely as the square of distance. So I'm going to have to take the d and put a second power on it in order to get the right answer. Okay, once you have your equation, you now need to find your k. So they should give you some numbers to substitute in. So it says if the illuminance is 80, so that goes where my I is located, at a distance of 5. So that goes where the d is located. Don't forget to square it. You should be able to figure out your k. Now, first thing you want to do is your exponents. So 5 squared is 25. And then to get rid of your fraction, you're going to multiply both sides of the equation by 25. And this will tell you what your k value is equal to. So we'll take 25 times 80, which is 2,000. And now we can write our equation. So I equals 2,000 over distance squared. Now, this problem didn't ask you to do anything else, so you're finished. All they wanted in this was for you to find an equation, so you can stop at stage 3. If they ask for more information, you'll have to do a stage 4 afterwards, but this problem, you're all set. Okay, the last type of variation is called joint variation. Joint variation is the same thing as direct variation, but it includes multiple variables. An example of direct variation would be something like y equals k times x times z. Notice that everything's multiplied. You still have the k, you still have the constant of proportionality. You just have more than one variable on the right-hand side. So here's an example that would include joint variation for you. The area A of a triangle varies jointly as its base b and its height h. Okay, so you can stop right there and you could write an expression for that or an equation for that. Okay, so if we start with step 1, the area A varies jointly as its base b and its height h. So you would take k times b times h because they said the word jointly. Always translate first. Now they should give us some numbers, so let's see what numbers they give us. If the area of a triangle is 48 inches, when its base is 12 inches and its height is 8 inches, find the area of the triangle whose base is 15 inches and whose height is 12. Sorry about this label. This is supposed to say squared inches there. Okay, so the area of the triangle is 48 square inches. The inches is just a label, so you don't need to square the 48. The base is 12, and the height is 8. Okay, so use that information to figure out your K. So first take your 12 times your 8, which is 96. And then you're going to have to get your K alone, so we'll have to undo the multiply by 96. The opposite of multiplication is division. And if you take 48 divided by 96, you're going to get a 1/2. You can do 1/2 if you want. If you prefer decimals, you can do a 0.5. That's also okay. Okay, so if we rewrite our equation, the area of a triangle equals 1/2 the base times the height. That should look familiar because if you've had a geometry course, you should have seen that somewhere before. Okay, now let's answer their question. Find the area. So I have no idea what my A is. When the base is 15 inches, so where the B is located, I'm going to substitute in 15, and the height is 20. I'm going to let my calculator do that multiplication for me, and this should come out to be 150. Now, if you're good about labeling, since this is area, you should label it as square inches. Like that. Okay, sometimes you'll have situations where direct variation and inverse variation and joint variation can all land in the same problem. If that happens, you're dealing with a combined variation. There's no one formula for combined variation. You simply have to read through the problem and translate it based on what is said. So as an example, the load L that a horizontal beam can safely support varies jointly. So L varies jointly. So remember, if you vary jointly, you're going to multiply the K. It varies jointly as the width W and the square of the depth D. Okay, and it is also inversely, so that means we're going to have to divide, as the length L. Express capital L in terms of WDL and the constant proportionality K. All right, this is all they were looking for in this case was a verbal translation. So we should have L equals KWD squared all over little l. We have another example here where they're going to ask you to do a little more with it after the fact. Okay, the owners of Henrietta Hots find their weekly sales of hot dogs S vary directly with their advertising budget A and inversely with their hot dog price P. Okay, so from that information, you can do a verbal translation. So let's do that. S varies directly with A, so that would be K times A, and inversely with P, so divided by P. Okay, so the sales varies directly with advertising and inversely with price. So basically, the more they advertise, the more they're going to sell. The higher the price, the less they're going to sell. Okay, now notice they gave us some numbers here at the bottom. When their advertising budget is $600, so the advertising budget was A, which goes next to the K. When their advertising budget is $600 and the price of a hot dog is $150, so the price of the hot dog went under the K, they sell 5,600 hot dogs a week. Okay, so from this, we should be able to figure out our K. Personally, first thing I would do is simplify the 600 over 150. 600 over $1.50 is 400. And then you got to get your K isolated, so you're going to have to divide both sides of the equation by 400 to get K alone. So 5,600 divided by 400 is 14. So your equation for this situation would be S equals 14A over P. Now on the next slide, they're going to ask you to use that to do some information. Okay, so the first question said, write a variation expression S in terms of A and P. Include the value of the constant of proportionality. Okay, we already did that. We came up with S equals 14A over P. That's our answer to part A. Now we're going to have to use that to do the part B portion. Find the expected sales of if the advertising budget is $800 and the hot dog price is $1.75. Okay, so this time they increased the advertising budget to $800, but they also increased the price of the hot dog to $1.75. How much are they going to sell this week? So I would like to do the numerator first, 14 times 800. 14 times 800 is 11,200. And then I'm going to divide that by $1.75, which is 6,400. So even hot dogs. So even though they raised their price a little bit from the $1.50, because they put more money into the advertising, they still sold more hot dogs. Okay, guys, give this homework a try. Let me know if you have questions. Thanks.